Hello students, I am Manoj Kundare, the Assistant Professor of Electronic Science. Welcome back to our e-learning platform. In this video, we are going to start the fourth chapter of the subject named as Power Supply. First of all, we have to know the important terms regarding to the power supply. That means what is meant by AC or what is meant by DC or what is meant by regulated or unregulated power supply. Okay, let's see one by one. First of all, we are going to see what is an AC or alternating current. Alternating current describes the flow of charge that changes the direction periodically. That means the alternating current is a current which changes its direction periodically. That means sometimes it contains positive value and sometimes it contains negative value. This is the waveform of the alternating current is shown, in which we can see here that this waveform is of sinusoidal type. That means it contains some positive part as well as some negative part after the fixed interval of time. Okay, I hope you all understand what is meant by the AC. Let's see once again. AC, that means the alternating current is a current which has the positive as well as the negative values. Okay, that means as a result the voltage level also reverses with the current. AC uses to deliver power to houses, office buildings, etc. In our house or in our buildings, this power supply used is of the alternating type or the AC type. Okay, we all familiar with this current. I hope you all understand what is meant by AC supply. Then the next important term is that what is an DC or direct current. The direct current describes the unidirectional flow of charge. The direct current is produced by sources such as batteries, power supplies, etc. This is the flow of direct current. This current flows in only one direction. This current direction is not reversal. Okay, this is the waveform of DC voltage is shown, in which we can see that the DC voltage have the fixed value of voltage. This is the very important term here, that the DC voltage is fixed value of voltage. Okay, here we can see that the AC voltage and the DC voltage. AC voltage means it has the positive as well as negative values. That means here the current flows in the both direction, in this direction and in this direction also. But in DC supply the current flows in only one direction, like this. For example, here we can see that the current flows from negative to positive. This is the electron flow negative to positive in only one direction. But in AC supply, here current flows in both direction. That means from this terminal to this terminal and from this terminal to this terminal. Okay, here are the two types of current flows. Hence it is called as the alternating current. While the direct current, the current flows in only one direction and it has a fixed value. Okay, I hope you all now understand what is meant by alternating current and what is DC current. The alternating current is used in our day-to-day life in our houses for the uh, fan or for the fridge, etc. But the direct current is obtained from the batteries or the power supplies. For example, we use a charger to charge our mobile. This charger, the output of the charger is of the DC type. Okay, now let's see the next term. What is power supply? The power supply is an electronic device which supplies electrical energy to the load. The primary function of the power supply is to convert one form of electrical energy into another. Hence, it is called as the electrical power converters. That means the power supply, we can say that the power supply is the electrical energy converters. For example, we all have a cell phone and we require to charge it. But here is a charging circuit is given and the circuit is operates on D means 230 volts, that means on the AC voltage. Here the circuit converts this 230 volt into the DC 5 volt or 12 volt. Okay, that means here the circuit converts 230 volt power into the 5 volt DC power. Hence it is known as the power supply. I hope you all understand. Now let's see the next term, the regulated power supply. A regulated power supply converts unregulated or alternating current to constant DC or direct current. A regulated power supply is used to ensure that the output remains constant even if the input changes. A regulated power supply or DC power supply is also known as a linear power supply. The regulated power supply will accept an AC input and gives a constant output. That means we can say that if this is the regulated power supply, then the input of this regulated power supply is of unregulated AC and its output is of DC type. Okay, I hope you all now understand what is meant by regulated power supply. Okay, now let's see the block diagram of the regulated power supply. In this block diagram, we can see here that there are different blocks present such as transformer, rectifier, filter, regulator and load, etc. Let's see the description about each block one by one. The basic building blocks of regulated power supply are as follows: step down transformer, rectifier, DC filter and regulator. Okay, the first block is the step down transformer. Here we know that there are three types of transformer. First one is isolation transformer, second is step down transformer and third one is step up transformer. Okay, the transformer is chosen according to the application. Here we want to use a regulated power supply which is of having the values plus 12 volt DC or plus 5 volt DC. For that purpose we use here the step down transformer. Okay, I hope you all understand why we use a step down transformer. A step down transformer will step down the voltage from the AC mains to the required voltage level without changing the frequency. That means the transformer has the input 230 volt AC and the frequency 50 Hz, but the output of the transformer is of, for example, if we want to build a power supply for plus 12 volt, then the output of the transformer is of 12 volt AC and having constant frequency 50 Hz. Okay, I hope you all understand. If we want to build a power supply for plus 5 volt DC, then the output of the transformer is 5 volt AC. Whatever is the value of the output voltage, the frequency is constant as the input. The input has the frequency 50 Hz and the output has the frequency also 50 Hz. The only difference in that the input voltage is larger than the output voltage. Okay, this is happen in case of the step down transformer. The turns ratio of the transformer is so adjusted so as to obtain the required voltage value. The transformer's primary winding is connected to the AC mains and the secondary of the transformer is connected to the rectifier circuit. We know that the transformer has the two windings. That means this is the transformer winding. Okay, this is known as the primary winding and this is known as the secondary winding. At the primary winding, the 230 volt AC supply is given, and at the secondary winding we get plus 12 volt or plus 5 volt supply, and this output is connected to the rectifier block. Okay, now let's see the next block, the rectifier. This is the rectifier block. A rectifier is an electronic circuit which converts alternating current, the AC, into direct current. That means the electronic circuit which converts AC into DC is called as the rectifier, and the process of conversion of AC to DC is known as rectification. There are mainly two types of rectifiers. First one is half wave rectifier and second one is full wave rectifier. The full wave rectifier further divided into two types: center tap full wave rectifier and bridge full wave rectifier. Okay, in this diagram we can see here that this is the input waveform and is of AC type. Okay, this is the output of the transformer, and we can clearly see that the magnitude of this waveform is less than the waveform at the input side. Okay, that means the voltage level reduce here. Then this waveform or this output is connected to the rectifier. We know that rectifier converts AC into DC. Here we get this output at the rectifier. Okay, this is the output of the rectifier, in which we can say that this is not a pure DC. This is not a pure DC, it is in pulsated form. Okay, it is a pulsated form, or this DC contains some AC plus DC values. Okay, I hope you all understand the concept here. Let's see once again. The rectifier converts AC into DC. Here the AC waveform has some positive values and some negative values, but the output of the rectifier is of DC type because it has only positive values. There are no negative values. So we can call this output as a DC output, but this output is not pure in nature. This is impure DC, or it is also called as the pulsated DC. Okay, now let's see the next block, filter. The rectified voltage from the rectifier is a pulsating DC voltage having very high ripple content. This is a pulsated DC type voltage, and it has the very high ripple content. Ripple content means the presence of AC component. That is, the output of the rectifier is not in the pure DC form, it contains some AC components. Here, the output of the rectifier contains some DC as well as AC components. A filter is an electronic device which removes the AC components of the rectified output but allows the DC component to reach the load. Filters are classified into four types, namely capacitor filter, inductor filter, LC filter, and RC filter, and CLC filter. Okay, this is the output of the filter. We can clearly differentiate these two waveforms. In this waveform, we can see here that there are large number of ripples. Okay, but in this waveform, the ripples are reduced in great extent. Okay, hence to smooth or to smoothen this output, we require to use a filter block or a filter circuit. We get here the smoothen the output or smooth DC voltage. But here we can see here that this output of the filter is also not in pure DC form because it contains some amount of ripples in it. Okay, here the large amount of ripples are present, and here the small amount of ripples are present. Hence this filter or this filter output is also not in pure DC form, it contains some AC component. Okay, hence to reduce this ripples, we have to use a regulator circuit or the regulator block. Okay, let's see the function of the voltage regulator. A voltage regulator in the regulated power supply is essential for keeping a steady DC output voltage by supplying a load regulation as well as line regulation. That means the voltage regulator is an electronic device which gives us the steady, that means constant voltage level. Okay, a regulator will maintain the output constant even when the changes at the input or any other changes occurs. The transistor series regulators, fixed and variable IC regulators, or a Zener diode regulators can be used depending upon their applications. ICs like 78XS and 79XS, that means 7805 or 7812, are used to obtain the fixed values of voltage at the output. Okay, that means in short we can say that the regulator is an electronic component or a device which is used to give a constant voltage level even when the input level changes at the some values. If input voltage level changes because of any sudden change or any factors like the temperature etc, then the regulator keeps the voltage of the output is constant. Okay, I hope you all understand the function of voltage regulator. Let's see once again. Here is the block diagram of the regulated power supply. The first block of this power supply is transformer. We know that transformer is a device which provides the isolation between input and the output. It converts one form of voltage into the another form. That means at the input it has the value 230 volt. Here we use the step down transformer. Depending upon the application, if we want to build a power supply for 12 volt, then the output of the transformer is 12 volt AC. This difference is clearly shown in this diagram. That means the input is 230 volt AC and the output is 12 volt AC. This is the waveform for 230 volt AC and this is the output of, this is the waveform for 12 volt AC. We can clearly differentiate between these two waveforms, but the transformer keeps the frequency constant. That means it at the input it has the frequency 50 Hz, at the output it has the frequency 50 Hz constant. Okay, here we use the step down type transformer and the step down value is decided by the number of turns in the secondary. Okay, this is the symbol of step down transformer. Now the output of the transformer is given to the rectifier. That means the rectifier is an electronic device which convert AC into DC. Okay, there are three types of rectifier: half wave rectifier, full wave center tap rectifier, and full wave bridge rectifier. The rectifier converts AC into DC. That means this is the input of the rectifier which has the AC component, and the output of the rectifier is in the DC format. That means here we can see that the negative part is present, but in this waveform the negative part is not present. Hence we can call this waveform as the waveform of the DC. But this waveform has the very large number of ripples. That means it contains some amount of AC component into it. Hence it is called as the pulsated DC. Okay, let's see once again. The output of the rectifier is in the pulsated DC form. Note here that the pulsated DC means, note here that the pulsated DC means the impure DC. Okay, pulsated DC means impure DC, means it contains some AC plus DC component. Okay, and it has the large number of ripples. To reduce these ripples we have to use the filter block. Okay, the filter block is used to smooth the output of the rectifier. There are various types of filter depending upon the components used. For example, capacitor filter, inductor filter, capacitor and inductor filter, and CLC or pi filter, etc. Okay, then the output of the filter is having the small number of ripples or less ripples, hence but the output of the filter is not also in the pure DC form because it contains some amount of ripples. Hence, to obtain the pure DC, we have to use regulator block. The function of the regulator is to, to steady or to make a constant voltage at the output. Okay, that means the output of the regulator is of the constant voltage or the fixed value of the voltage. Hence, this is the pure DC output. I hope you all understand the block diagram of the regulated power supply. Thank you.